This video is your guide to the Unit 1 review packet. It's going to be split into 3 parts, with each part dealing with one topic on the review packet. For 1 through 6, we're going to use the diagram over here. Number 1 says name 4 rays that use B as an endpoint. To name a ray, we have 2 components. First, we have to have an endpoint, which is where the ray starts, and then we need another point, which acts as a direction for the ray to go. This specifies we have to use B as an endpoint, so we know that all of our rays have to start here, and then we need to pick another point as the direction for that ray to travel in. So we could name ray BA, which would start at B, go through A, and name 4 total. We'll probably have to use all 4 of these. So that would give us BA, BE, BC, and BD. To name a ray, we list the points with the endpoint first, so we'll start with BA, and then above it we draw the ray symbol, which is a line segment with an arrow on one side. So we'd have BA, BC, BD, and BE. Number 2, name line L 4 different ways. To name a line, we use 2 points that are on that line as well as the line symbol above it. So line L has 3 points we can use on it, E, B, and D. So I just need to pick some combination of 2 of those and put the line symbol over it. So I could call this EB, ED, and I can switch these around, BE and DE. There are a couple other ways you could do this. For example, you could just write line L. However, whether that will give you credit or not is questionable, given that it says line L in the question itself. Name 2 pairs of opposite rays. Opposite rays are rays with the same endpoint, but go opposite directions, so they make a line. This picture only has 2 lines in it, line L, which we saw earlier, and this line right here, AC. Each of these lines is going to be made up of opposite rays. So line L would be made from the rays BE and BD. Notice how they have the same endpoint, but they go opposite directions. So that would be 1 pair. The second one would be BA and BC. Number 4, name 2 pairs of adjacent angles. Adjacent angles share a vertex and a side. So there's a lot of potential adjacent angles we can name here. These 2 angles, for instance, are adjacent, as well as these 2, and these 2. So we just need to pick 2 angles that are next to each other and then name them using 3 points. I'm just going to use the 2 that I already identified. So this one right here, we could name DBA. And the second one would be ABE. To name a second pair of adjacent angles, I can just pick the one that's next to this, which would be EBC. So I'll start with the ABE from earlier and add EBC. When naming an angle, we use the angle symbol, as well as put the vertex in the middle and the 2 other points on the outside. Number 5, name 1 pair of congruent angles. You ignore the mark I made earlier, we have these 2 angles that are marked congruent. Now, it wouldn't actually matter if they were marked congruent or not. These 2 angles are vertical to each other, so they have to be the same. This is also true of angle ABD right here and EBC. Even though these are not marked congruent, they are, because they're vertical angles. So I need to pick either these 2 or these 2, and those will be my congruent angles. Because these are marked, we'll just use those. So this one would be ABE, so write angle ABE, and angle DBC. Name 1 pair of congruent segments. Unlike angles, where vertical angles automatically means congruent, there's no rule that automatically means segments are congruent. So we have to have segments that have the tick marks on them to show they're the same. This segment has 2 tick marks on it, so does this. As long as they have the same number of marks, it means they're congruent to each other. So that would mean that DB and BE are congruent. Mark true or false, fix the statement if it is false, so it is true. Number 7, if 2 segments are congruent, they will have the same number of tick marks. Well, that's pretty much exactly what we just said about those. This is true. Number 8, Segment AB represents the length of segment AB. When we write two letters with a line or the segment symbol on top, it means we're talking about the name of the segment, not the length. So we need to change this by removing the segment symbol and rewriting it without. Over here, if we want to name the segment, we would put the segment symbol over it. So this one was false. Finally, the last one. 4 points are collinear if they are all on the same line. Well, the definition of collinear is points that lie along the same line. This is the definition of collinear, so yes, that would be true. Draw an angle to fit each description. Number 10, a 90-degree angle named Fox. To draw an angle, it's usually easiest to start with a right angle and then either shrink it or enlarge it based on what you need. 60 degrees is about 2/3 of 90. So to make a 60-degree angle, I'll draw a 90 degree and then just go up about 2/3 of the way. And that would be my 60-degree angle. I'm going to erase the rest of this off because we don't need it. And then it said to label it Fox, F-O-X. Over here, a right angle named cat. Well, if I can draw a right angle for this, all I need to do is draw a right angle and label it C-A-T. Use the illustration on the right for problems 12 through 14. Number 12, name an obtuse angle. An obtuse angle is any angle that's larger than 90 degrees. There's a couple potential obtuse angles here. We have RMU, which is definitely greater than 90. We have VMS, which is also greater than 90. And we can pick either one of those. I like RMU, so I'm just going to say that this thing would be angle RMU. Name a straight angle. A straight angle is any angle which is 180 degrees. The easiest way to spot a straight angle is to look for a straight line. In this picture, I only see one straight line, and that's this one right here. So I will call this angle RMV. And last, name an acute angle. An acute angle is less than 90. I see 1, 2, 3, 4 here that are less than 90 degrees, so I just need to pick one. RMS is the first one I see, so I'm just going to name this RMS. Number 15, 16, and 17. Name the relationship, complementary, linear pair, vertical, or adjacent. Use all that apply. For number 15, we have two angles that are clearly adjacent. They share a vertex here, and they share a side in the middle, so we will say they are adjacent. However, over here we have this 90-degree angle symbol, telling us that this is a right angle. Well, this whole thing is a straight line. If this portion of it is 90, and the entire thing adds up to 180, then that means 180 minus 90 would be 90. These two angles have to be 90 in order to make that straight line, which means A and B add up to 90. That makes them complementary. For 16, these two angles form a straight line together. One thing you can do to help is you can use a piece of paper to cover up the extra pieces of information here. If I just cover up the other half of this line segment, that line, then it's pretty easy to see that these two make a straight line together. That means they're a linear pair. And because all linear pairs are adjacent, we'll add adjacent to that as well. Finally, number 17. These are not adjacent. They share a vertex, but they don't share a side because they're on opposite sides of an intersection. If I use my same trick, there's a little bit of paper to cover up the extra information I don't need, these two are actually on opposite sides of an intersection, A and B. That makes them vertical. I don't know anything about their size, so I can't say whether they're complementary or not, but I do know that they're vertical. Number 18. Why can't we name an angle using a single letter when the vertex is shared by more than one angle? Use an example to help justify your response. So I've drawn a picture with multiple angles that all share the same vertex B. It wouldn't make sense to say angle B because if we said angle B, nobody would know if we were talking about ABC, ABD, ABE, or CBD, DBE, ABD, etc., etc. There's a lot of angles here that all correspond to angle B, and there's no way to know which one someone's talking about if they just say B. We don't use single letters when the vertex is shared because you wouldn't know which angle it referred to. Number 19, when we name a ray, why is the order of points important? Say I have a line AB. If I name the ray BA, that means start at B and go towards A. That would be this orange ray right here. If I were to switch it around, AB would be start at A and go towards B. The order changes the ray. BA and AB are not the same. They go in opposite directions, and they even overlap each other a little bit. So why is the order important? It reverses the direction of the ray and the start point. Number 20. If two angles form a linear pair, do they have to be adjacent? Supplementary. Use examples to help justify your response. Linear pairs, the definition is adjacent and supplementary. They're two angles that form a straight line. There's no way that two angles can form a straight line together unless they're adjacent. If they weren't touching, they wouldn't form a straight line. And they have to be supplementary because if they do form a straight line, then they have to add up to 180.